Hello and welcome to Home Science Lessons of Mr. Mac. Lesson 4 of particles, specific latent heat. So please remember, get a pen and paper, have it ready. You probably won't need a calculator for today, so don't worry about that. Switch off any of devices, any other distractions, and get ready to concentrate and have a really good physics lesson. All right then. So the lesson will take the usual format, 3 slides of retrieval practice, some teacher instruction under the camera with myself, a chance to drill and embed the new knowledge, and then a chance to practice applying the new knowledge that you've learned. First slide is on waves, this retrieval slide. So please get your pen and paper ready, pause the video and have a go now. And there are the answers with a picture or model of a longitudinal wave at the bottom. Next slide. This one is about structures and bonding, covalent bonds specifically. So pause the video and have a go now, please. And there's the answers. Last slide today for retrieval practice is on health and infection. So get your pen and paper ready, pause the video and have a go now, please. And there are all the correct answers for you. So as always, if there's any answers that you got wrong, please make a note of them, and then please go back and do some revision on the parts that you didn't know. So last lesson we did some work on particle theory, and here was the question for slop 3, the first question. So if you didn't do this last time, you could pause and have a go. Here's the second part of slop 3. Again, solids, liquids and gases and particle knowledge. Again, pause and have a go if you haven't done this last lesson. And here are the answers for question 1 and question 2. So question 2, you pick out 2 or 3 points from solids, gases and liquids in order to get maximum marks. Because you have to mention the energy and the arrangement in your answer and the movement of particles. What about new knowledge for today then? So we're going to look at something called latent and specific latent heat. So get your pen and paper ready to make your new notes on this. And we're going to go onto the camera to make some new notes. So first of all, we got our definition of latent heat. So what is latent heat? Latent heat is the energy needed for a substance to change state. So that means to turn from a liquid into a gas or solid into a liquid or whatever. So the energy needed for a substance to change state. So that's latent heat. And the temperature stays the same when there is a change of state. And there's another definition that you need to know, and that is the one for specific latent heat. So we're going to put this just in here because that's what it actually says there anyway. The amount of energy required to change the state of 1 kilogram a substance with no change in temperature. So latent heat is the energy needed for a substance to change state, and specific latent heat is the amount of energy required to change the state of 1 kilogram of a substance with no change in temperature. So it's the latent heat for a specific amount of that substance. What are the two types of specific latent heat? Well, here they are. Latent heat of fusion. So this is the energy needed to change state from solid to liquid. So latent heat of fusion is the energy needed to change state from solid to liquid. So for a particular substance, how much energy it takes to make it change from solid to liquid. So the other specific latent heat is latent heat of vaporization. Latent heat of vaporization. And this is the energy needed to change of state from a liquid to a gas, in brackets vapor. So I'll run through that one with you again. The energy needed to change state from a liquid to a gas or vapor. Now we've also got this what's called a heating curve down below on the graph. So it's for a substance, as it's being heated and temperature is increasing over time, the temperature doesn't rise constantly. You can see that it rises, levels off, and then rises. And this is what's happening at each part. So between A and B, you've got a solid. And between B and C, the solid is melting. And the reason why the temperature doesn't go up is because of this latent heat of fusion. That's the energy needed to cause it to change from a solid to a liquid. What happens between C and D? We've now got a liquid, temperature is increasing, and then when we get to D, we have got boiling. So we've got a liquid turning into a gas. And from E to F, temperature rises again, and at this stage it's a gas. So you may want to pause the video and make a note of the definitions and the new information if you haven't had a chance to write it all down already. And that's our new knowledge for today. So what we now need to do with that new knowledge is to drill, 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 because drill is thrill. How do we do that? We get the notes from our new knowledge, we cover it up, and we write what we can remember on a blank piece of paper and then check to see if it's correct. So look, cover, write, check. Obviously take a while to read over it first. Or the other way that you can drill, drill, drill at home is if we have read over our notes and we give it to someone at home and they test us on this new information and see if we know it. So just some notes and information to go alongside the information that we went through under the camera. So latent heat is the energy required to change state or for a change of state. And latent heat of fusion changes a solid to a liquid. Latent heat of vaporization changes a liquid to a vapor. So we can see in the diagram what's happening to the particles. And there's some more information there. And what you may not have realized before is if you have a glass of drink and you put ice in it, you can expect its temperature to drop until it's close to 0 degrees C. And your drink will remain cold regardless of the outside temperature, as long as there's still some unmelted ice in the drink. Because as the outside environment warms up, some of that energy is taken in to be the latent heat to turn the ice into a liquid, and that keeps your drink cold. So latent heat can sometimes be called invisible heat because we don't see an increase in temperature at that time. So what about latent heat of vaporization? So that is the energy that must be supplied to a liquid to allow the particles to break free from their attractive forces and to turn into a gas. And again, that's invisible, and the temperature will not rise above the boiling point as a liquid turns to a vapor. And there's a typical heating curve that we went through on the new knowledge earlier on. So we got solid, melting, the temperature staying the same, liquid, temperature rising, and then when we get boiling, the temperature levels off again. So next, I've got a slop task for you to do a little bit of recap on particle theory and also to have a go at applying your new knowledge on latent heat. So there are a few questions here. So there's question 1. This is also attached to show my homework as a Word document. So you can either write down your answers off the screen now, or you can print it off and then write it down in your leisure. So pause, have a go. Next part of slot 4, you need to explain what is happening between A and B and C in the graph. Pause, have a go. Question 2 is a question about specific latent heat of fusion. So have a go at that and try and explain why if the road surface is black, the system would work well. And the answers to those will be revealed in our next lesson. Pause and have a go now, please. Speaking of next lesson, it's going to be all about calculating internal energy. So until then, make sure you do some retrieval practice of old topics, complete the slot tasks, share the video with anyone who hasn't gotten bored with online lessons, and make sure that all your buddies know about it. And it just remains now for me to say, see you soon. Thank you in advance for working hard. Thank you. Goodbye.